Welcome everybody to Algebra 1, Section 2.2, two-step equations. So two-step equations, we have multiple operations going on, so we have to figure out what order are we going to be doing them. Now, typically when we're going through what order we do things in, we go back to PEMDAS, parentheses, exponents, multiplication and division from left to right, addition, subtraction from left to right. However, to solve equations with more than one operation, we undo operations by working backwards. Kind of like the difference between taking something apart and putting something together. You go in the opposite steps. So we'll reverse it to SADMEP, where typically we undo the addition subtraction first, and then we undo the multiplication division first. So here on number 1, solve the equations, check your solutions. Our x, what is happening to it? It's being multiplied by 6 and added by 8. And like we saw up above, we're supposed to undo the addition and subtraction first. So we undo the addition of 8 by subtracting 8 from each side of the equal sign. 8 minus 8 is 0, and we get 6x equals 42. Now this turns into a one-step equation, where to undo the multiplication of 6, we divide both sides by 6, giving us x equals 7. I'm going to go ahead and show how to plug this back in. You would take 6 times 7, 6, 7, and say, does this equal 50? So we get 42 plus 8, and that equals 50, and that does in fact check out. 42 plus 8 is 50. I'm not going to be plugging in into future problems now that we know how to do it. That's always an option available to you to check your work. If you had on this problem, I want to note, tried to divide by 6 first, I want to know what would happen here. So if we try to divide by 6, we get x plus 8 equals 50 divided by 6 is 25 over 3. Then we try and subtract 8, and as you can tell, it's getting pretty messy here, to where we end up having to do 25 over 3 minus 24 over 3. That's what this would be as thirds. And then we end up getting x equals 1/3, which is very obviously different than the answer 7. And if we plug 1/3 back in to check our solution, it would be incorrect. And the reason why is you technically would have to divide everything by 6 in this first step. So instead of just dividing the 6x and the 50 by 6, you'd have to divide everything by 6. And then this would become 4/3. And that gets messy. That would work, and that'll get you the correct answer if you do it that way. However, it gets a lot messier. So our math is much simpler or more straightforward if we follow what we're talking about up here, doing SADMEP rather than PEMDAS. Number 2 here, 2n minus 5 equals 11. So we have our variable being multiplied and subtracted. We undo the subtraction of 5 first by adding 5. We end up getting 2n equals 16. Dividing both sides by 2 to undo the multiplication yields or results in n equaling 8. Next up, number 3, we have our k being multiplied by -4 and added by 9. We undo the multiplication first, undo the addition first by subtracting 9 from both sides, giving us 4 equals -4k. Then we'll divide both sides by -4, which results in k equaling -1. If you wanted to flip it around so the k is on the left, that is okay as well. Number 4 here, 7 minus 3y equals 34. So this minus tricks some people. We've got to be very careful with that. The minus is really attached to this 3y as a negative. We have to undo the 7 first, however, like we have in our previous problems, but this 7 is positive. If we try adding 7, we get 7 plus 7, which is 14. And that is not what we want. We want to get that 7 away, not make it bigger. So instead of adding 7, we subtract 7, because a positive 7 minus 7 is 0. And so we minus 7 from each side, and on the right side we get 27. On the left side we have this 3y, but this negative stays with the 3y. Now we divide by -3, and we get y equals -9 as our answer. Moving on to number 5 here, our x is being divided and subtracted. We undo the subtraction first by adding 7, and we get x over 2 equals 16. We multiply both sides by 2 or 2 over 1 to undo the division, and we end up getting x equals 32. On number 6, similar scenario here, c is being divided and added, so we undo the addition by subtracting 8, and we end up getting, as my iPad glitched out there, 3 equals c over -5. If we multiply each side by -5 or -5 over 1, we undo the division, and we get c equaling -15. Moving on to our next page for example 7. 3 over 5x plus 22 equals 28. So undo the multiplication and addition. The addition comes first by subtracting 22. 3/5 x equals 6. Now to undo the fraction multiplying with the variable, as my iPad once again decides to wig out on me and then move me back to the previous page for some reason. It doesn't want to erase that. Well, I guess that circle's staying there. That's okay. So 3/5 x equals, as it erased on this one though, 6. Let me write that in green to match what I had before. I apologize for my iPad wigging out. I wish I had the answer to that. To undo this fraction with the variable, we don't divide by another fraction. That would make our math quite complex. Oh, the circle finally erased. Neat. Anyway, instead we would multiply by the reciprocal, 5 over 3. The 5's reduced, the 3's reduced, and we're left with x. Multiply this side by 5 over 3. I'm going to put the 6 over 1 to make my life easier. 6 and 3 diagonally reduced by 3 to become 2 and 1. And multiplying straight across gives me 2 times 5, which is 10. On the bottom we have 1, but 10 over 1 is just 10. On number 8, once again we undo the addition here first by subtracting 1. So we get negative 1/3 m equals negative 8. Multiplying by the reciprocal here is negative 3 or negative 3 over 1. Where we put the negative on the fraction does not matter because regardless, a negative times a negative is a positive. So as we reduce, we get positive 1m. On the other side, we get positive 24. On number 9 here, we undo this negative 10 adding with p. So how do we undo a negative 10 even though there's a plus sign here? If we were to subtract 10, I should say, this would combine to be negative 20. That's the opposite of what we want. We want to make it smaller, go back to 0, not bigger. And so we add 10, and that gets it to 0 like we want. And so we add 10 to the other side as well, and we get negative 28. Multiplying by the reciprocal, 4 over 7, 4 is reduced to 1, 7 is reduced to 1, and we're left with p, or 1p. Multiply the other side by 4 over 7, and putting negative 28 over 1 to make my life easier. I can reduce 28 and 7 by 7 to become negative 4 and 1, and multiplying the numerators results in negative 16 being my answer. Number 10 here, 9 minus 1/2 x is what's on this side, so we need to undo the 9 first. This 9 is positive, so we do not add 9, even though this minus sign's here. We subtract 9. That minus sign over here is for the 1/2 x. So we subtract 9 and get 6 equals negative 1/2 x. Now I undo this multiplication of negative 1/2 by multiplying by negative 2 over 1, the reciprocal. Once again, where the negative is on the fraction does not matter. Negative 2 over 1 is the same thing as negative 2. So here we end up getting a positive 1x as we do a negative times a negative. On the left-hand side, we end up getting negative 12. Now here it says, watch out! The examples below are different in that the multiplication and division is done first, followed by the addition and subtraction. And let me explain why that is. So you'll notice a fundamental difference here between problems such as number 5 and 6, where only the variables being divided in each of those, but the part that the constant term that is adding or subtracting is not being divided. It's not part of the fraction. And so in those, we dealt with that constant term by adding or subtracting first. Here, on these 4 examples, we notice that the entirety of the one side of the equal sign is being divided. So here, the positive 11 is part of the fraction, the minus 5 is part of the fraction, minus 13, and the plus 8 are all part of their fractions. Meaning, even though we'd love to get rid of this first, and we're supposed to get rid of it first typically, we can't here because it's part of the fraction. So we have to make it no longer part of the fraction, meaning we have to undo the fraction first, which means we undo division first, because fractions are division. So we undo division of 8 by multiplying by 8, or 8 over 1. The 8's reduce to become 1 and 1. And so technically you would take 1 times everything in here, but 1 times anything is itself, which will happen every time when you are reducing here to undo the fraction. So you get x plus 11 equals negative 24. Now we can finally subtract 11 because it's no longer part of our division, no longer part of the fraction. And we get x equals negative 35. I'm going to go ahead and plug this back in here just to showcase that it does in fact work. And so we'd have negative 35 plus 11 divided by 8 and asking does this equal negative 3? So the numerator here would result to negative 24, and negative 24 divided by 8, would that be negative 3? Yes, it is negative 3. I'm just going to say check. It works out. Now, I do want to mention the reason why we can't just subtract 11 here, not only, like I mentioned, is it part of the fraction. If we rewrite this, this is secretly this problem. We could split it up and make it two fractions over the same denominator of 8, with this symbol between the two. And now we notice it's not actually 11 that we'd be subtracting, it's 11 over 8. So if you wanted to, you could split the fractions and then subtract by 11 over 8. However, you're going to have to put the 3 over 1 and get common denominators, and that's a big pain. So rather than doing all that, we avoid it and say, let's just undo the fraction first, since the addition or subtraction, in this case addition, is part of the fraction. On number 12 here, once again, the subtraction is part of the fraction, so we have to undo the fraction first by multiplying by the denominator over 1. So negative 2 over 1. And negative 2 is reduced, and we get n minus 5 on the left. On the right, we get positive 14. Now, if we add 5 to both sides, we get n to be 19. I almost said 14 there. Number 13 here, once again, this entire side is part of the fraction, so we have to undo the fraction by multiplying by negative 6 over 1, the denominator over 1 on both sides. On the left, we get negative 6. On the right, these negative 6 reduce, and we get a minus 13. Now we can add 13 to both sides and get 7 equals a as our answer. 14. The plus 8 is part of the fraction, so we can't undo it yet. Instead, we have to undo the fraction by multiplying by the not the reciprocal, but the denominator over 1, 9 over 1. If there was like 8 over 9 times w, then you do the reciprocal. But here, when there's 8 is adding, we don't do the reciprocal. We just do the denominator over 1. So on the left, we get 36. On the right, those 9s reduce, and we're left with w plus 8. Subtracting by 8 gives us 28 as our w. Word problems. Woo-hoo! Exciting stuff here. So Susan had a $10 coupon for the purchase price of any item. She bought a coat that was on sale for half its original price. After using the coupon, Susan paid $125 for the coat before taxes. Susan is shopping the sales. What was the original price of the coat? Write an equation for the problem, then solve the equation. So as I mentioned in 2.1, a good step to do first in word problems is to underline, highlight, or circle key information here. So I would go ahead and pause the video, circle what you think is important, or highlight or underline in some manner, and then play the video to see what I believe to be important and compare it to you. So we don't really need to know that it's Susan, but we do need to know she had a $10 coupon for any item. And we do need to know that she bought a coat that was on sale for half its original price. We do need to know that it was after using the coupon that she paid $125 for the coat before taxes. We also need to know the question we're asking, which is what was the original price of the coat, and then that we're supposed to write an equation, then solve. So we end up having most of this be key information. So sometimes most of the problem will be key information, sometimes only part of it will. So a good second step after pulling out key information is to identify a variable and what that variable represents. Just like in all of our other problems up to this point, our variable is what we find or solve for. So what are we trying to find here? Well, the question tells us that. What was the original price? So we need some variable to represent the original price of the coat. You could use the letter C, for example, for a coat. You could use P for price. You could use X for just common variable. I'm going to go ahead and use C for coat here. Okay, once again, you could use any variable you'd like, as long as you define it as the original price of the coat. So here, we take the original price of the coat, and we know that she bought the coat that was on sale for half the original price. So that would be 1/2 times the original price of the coat. Then Susan used the coupon, which takes $10 off or subtracts the cost by 10. And that leaves Susan paying $125. So if we take the original price of the coat, C, we multiply it by 1/2 or divide by 2, it's the same thing, we get the sale price. Then if we subtract the $10 coupon, we get what she paid. Let's go ahead and solve this now. So we undo the subtraction first by adding 10. And we get 1/2 C equals 135. Next, we multiply by the reciprocal, 2 or 2 over 1. On the left, we get C. On the right, we get 270. I am a stickler for labels, so we need to note that it's $270. So Susan really got quite the deal compared to what it was originally. $125 is a much better scenario than $270. Next, another word problem. The larger of two numbers is 4 more than the smaller number. If the sum of those numbers is 74, find the numbers, write an equation for the problem, then solve the equation. If you're working on key information here, I'm going to spoil it and say the entire thing is key information on this problem. So let's define our variables. We're supposed to find the numbers. Okay, so numbers, plural. So we're going to have the first number, and we're going to have the second number. Now, we're told the larger of the two numbers is 4 more than the smaller number. So whichever one I call my smaller number, I'm just going to call it the first number here, and I'm going to call that x. Okay. Whatever we're comparing to, here we're comparing to the smaller number, comparing one number to the smaller number, the larger to the smaller. Whatever we're comparing it to, we're going to call our variable. So then the larger number, which I'm going to call the second number here, is 4 more than the smaller. So I'm going to take the x and add 4 to it, and now I have my smaller number. So for example, if my smaller number was 10, my bigger number is 4 more than that, 14. Now we know the sum of the numbers is 74, meaning we're supposed to add these together. So I'm going to take x and add it to x plus 4, and that's going to equal 74. Some of us might benefit from putting this in parentheses, knowing that this x plus 4 is the second number, and the x is the first number. And that way, some of us might visually see that, hey, we're adding one number to another number, even though there's x plus 4, 3 different terms. Now we're going to go ahead and combine like terms as we solve. So we have x plus x, and that equals 2x. So we have 2x plus 4 equals 74. That's a new step that we haven't done before, combining like terms there. Then we're going to go ahead and subtract the 4 because this becomes our normal two-step equations. So subtracting 4 from each side, I'm going to move it up here so I have room, gives us 2x equals 70. Now if we divide both sides by 2, we get x to be 35. So the smaller of the numbers is 35 because that's what we called x, meaning the bigger the numbers is 4 more than that, 39. So our two numbers are 35 and 39. And we don't need labels because these are just numbers. It's not like it's saying $35 and $39 or something like that. Once again, though, when you're comparing two different things, like the larger is something, something, something compared to the smaller, in this case 4 more than, the one that we're comparing it to, in this case the smaller, is our variable x, and the other one is a modified version, or x plus 4 in this case. Number 17. Garrett has $1 less than 3 times as much money as Liz has. Together they have $179. How much money does Garrett have? So we're trying to once again figure out two different people's amounts, similar to how we had two different numbers. We have two different variables here, the amount of money that Garrett has and the amount of money Liz has. And similar to number 16, all the information is key here. So we're going to have Garrett's money, and Liz's money. And since we're comparing Garrett's is a bunch of math, as Liz has or than Liz has, anything like that, we're going to make Liz the variable x, or whatever we want to call it. And then Garrett's is going to modify it. So $1 less than 3 times as much. So 3 times as much minus 1. Remember, less than means subtraction, but we got to flip the order. So we're going to do something minus 1. In this case, 3 times as much money as Liz has, 3x minus 1. Now we know together they have $179. So if we add their amounts together, 3x minus 1 plus x, knowing the 3x minus 1 is Garrett's, and the x is Liz's. And that'll equal the total of 179. Just like we did on number 16, we combined our x's. So here we're going to combine 3x with x, and we're going to get 4x minus 1 equals 179. Now we're going to go ahead and add 1 to each side, and I'm going to once again move this up here so I have some room, and have 4x equals 180. Now if I divide by 4, I end up getting x to equal 45. So that means Liz has $45. We're not asking how much Liz has though, we're asking how much Garrett has. So we have to plug it back in here to solve. Or you could say they add it to 179 and take 179 minus whatever Liz has, and that's the amount Garrett has. So whether you plug x back in here to get Garrett's amount, or you say 179 minus whatever Liz has is Garrett's amount, either way we'll get the correct answer. So let's just say I plug it back in on this problem. So 3 times 45 instead of 3 times x minus 1. 3 times 45 would be 135 minus 1. And 135 minus 1 is 134. So Garrett has $134. Now we're going to talk about consecutive integer problems. Consecutive just means things in a row. So consecutive integers are integers in counting orders such as 7, 8, 9. Now, remember, integers mean there's no decimals, no fractions, but they could be positive and there could be negative or 0. Now, if you begin with an even integer, actually, I'm going to come back to this. My apologies. I'm going to come back to these in just a moment, but we're going to start here with example 1, then I'm going to come back to that, okay? So here on example 1, write an equation for the problem, then solve the equation and answer the problem. Find 3 consecutive integers whose sum is 21. Now, I don't know any of the numbers currently. And rather than guessing and checking, what you could do here, and just plug in random numbers and see what adds up to 21, we're going to set up an equation because that'll help us be far more successful with more complex problems that may come later. So we're going to do our first number, our second number, and our third number, similar to how we did this on example 16 when we had 2 numbers and one was larger and one was smaller. Our first number we're just going to call x. Now if our first number is x, the second number is the next number after x. Well, if x is 4, for example, the next number would be 5. Or if x is 5, the next number is 6, and so on and so forth. Meaning we take whatever x is and we add 1 to that. And get the next number after that, we add an additional 1, which plus 1 is really just plus 2. So we take our first number, let's say it's 4, for example. We add 1 to it, we get 5. We add 2 to that original number, we get 6. So we'd have 4, 5, 6 consecutive numbers. And that would work with any potential x value. Now we're supposed to know that their sum is 21. So we're supposed to add these 3 things to equal 21. And I'm going to utilize parentheses here to help make this make sense. So we're going to have x plus 1 plus x plus 2 equals 21, with x being in the orange, x plus 1 being in the green, and x plus 2 being in the purple. So we're adding the orange plus the green plus the purple, the first plus the second plus the third consecutive numbers. We combine our x's here. We have x plus x plus x. That's 1x plus 1x plus 1x, which is 3x. We'll combine our constants, 1 plus 2, and get 3. And keep the right side the same. Now we have to get our variable by itself. So we have to do the same thing we did earlier in the lesson where we subtract the 3. I'm going to move this up here so I have room, and have 3x equals 18. Dividing by 3 results in x equaling 6. So our first number is 6, but we're supposed to find all 3 integers. So if our first number is 6, the next number would be 7, and the last number would be 8. 6, 7, and 8 would add up to 21, and they're consecutive integers. Number 2. Write an equation for the problem, then solve the equation and answer the problem. Find 3 consecutive odd integers whose sum is 57. That's new. So let's go to this bullet here. Beginning with an odd integer and counting by 2 will result in consecutive blank integers. Well, let's try this out. An odd integer would be 3. If I count by 2, I'd get 5, 7, 9, ... We notice this is just the next odd integer. So we get consecutive odd integers if we start with an odd and add by 2. So here, once again, we know we have 3 integers. So just like on the last one, I'm going to do a first number, a second number, and a third number. The first would be x, because we don't know it. We'll just call it something. The next number, we can't do x plus 1, because we have to have the next odd. So to go from one odd to another odd, or the next odd, we'd add 2. So it's x plus 2. And to go from that odd to the next one, we add another 2, which would be a total of 4. So if this first number was 3, adding 2 would be 5, and adding 4 to the original number would be 7. So we'd have 3, 5, 7. And we know their sum is supposed to be 57. So similar to the last problem, I'm going to add these up. X plus 2 plus x plus 4 equals 57. Once again, I'm going to use color coding to help me out here. X is the first number. X plus 2 is our second number. And our last number is x plus 4. So we have our x, our first number, plus x plus 2, the second number, plus x plus 4, the third number, all equaling 57. And similar to how we solved the previous problem, we're going to combine these x's. X plus x gives us 3 x's, and 2 plus 4 gives us 6. Now we're going to go ahead and subtract 6 from each side and get 3x equals 51. I need to go up here because I ran out of room, so I'm just going to rewrite it with no additional math in between right now. Dividing by 3 now to get x by itself gives me x equals 17. So if x is 17, the next odd number would be adding 2 more to get to 19, and adding 2 more from that to get to 21. And so we get 17, 19, and 21, 3 consecutive odd numbers. Number 3 says find 2 consecutive even numbers whose sum is 54. So we're not having to find odd ones this time, we're finding even this time, and we're finding 2 of them. Now, beginning with an even integer and counting by 2 will result in consecutive blank integers. Well, let's try it. So if I start with an even number, such as 2, and I add 2 to that 2, I get, if I can erase all of this that my iPad tripped out on. If I add 2 to 2, I get 4. I add 2 to that, I get 6. Add 2 to that, I get 8. 2 to that, I get 10, and ... forever and ever and ever. So we notice these are going to be consecutive even integers. So notice both for the consecutive odd and consecutive even, we count by 2. Now, the reason why that works for both of them, even though even and odd are obviously different than each other, is that it all matters with what you begin with. If you begin with even and count by 2, you'll get evens. If you begin with odd and count by 2s, you'll get odds. So here, how do we distinguish in this part, when we're defining our numbers, our first and second numbers here, that we need to find an even compared to an odd, like we did on the last problem? Well, the real trick actually is that you don't have to specify that it has to be even at this point in the problem. Once you set this one up the same way we did here, where we called our first number x and our second number x plus 2 to find the next even number, similar to how we did the next odd number was 2 more than the previous one. And we set this up as the sum, or adding, x plus 2 equals 54, which once again I'm going to use some color to help me out, x in blue, and I'm going to do x plus 2 in green. And these add up to 54. Once we solve this, we'll notice that this actually works out just fine to where it ends up being even numbers. So if we combine x plus x, we get 2x plus 2 equals 54. Then I subtract by 2, and I get 2x equals 52. Move this up here so I have some room. Then if I divide by 2, I get x equal 26. So that is my even number, even though before I got an odd number. Now notice that if you do the setup the same way on these, x and x plus 2 and x plus 2, it all depends on what number was over here, whether it was even or odd, which were given in the problem. So even though it says odd or even, you set them up the same way, and the answers will work out naturally by themselves to be what you want them to be or what it's asking them to be. So our first number is 26, and the next consecutive even would be 28. And that would wrap up this part of the notes. You can feel free to do this two-step equation on maze on your own if you'd like. How it works is you solve one equation, so such as this one, we subtract 10 at the start. 4x equals negative 36, my apologies. Divide by 4, and x equals negative 9. And because I got negative 9, I go down this path here. from the one. If I got positive 9, I would go down here. If I got negative 4, I go down here. And now I start working on this problem. And depending on what answer I get, I go down one of these other paths. You'll never go back down the same path you were just on. So because I just came from this problem down to here, I'm not going to get negative 9 from this problem and go back up. And the goal is you'll end up getting here if you do all your math correctly.